Alrighty, everybody, so here is a look at our cofunction identities. What these are basically saying is the trig function of an angle. My sine, cosine, tangent, cosecant, secant is equal to, equals the cofunction of its complement. And so what we're saying is the secant of theta is the cosecant of the angle that adds with whatever I gave you that equals 90. Because remember, a complement is two angles that add up to 90. So what we're saying here is this theta plus this angle. So what this function is saying is if you take theta and you add it to this, what you get is 90. And you can easily see that if you take theta plus 90 minus theta, you add those together, the thetas cancel out, you're left with 90. That's what it means to be complements. Alrighty, so whatever the magenta or I never know what that color is, pink, purple, magenta. So the first angle plus the second angle will equal 90. We can also say that with pi over 2, because remember, pi over 2 is 90. So instead of saying 90 here, we can say pi over 2, because we know that an angle plus another angle equals pi over 2, because when you're looking at your unit circle, pi over 2 is at 90 degrees. And we are going to be looking at the unit circle, obviously, quite a bit. So using these cofunction identities, let's find theta. And we're saying one value of theta because many values of theta could potentially work. We just want to find one of them. Notice that cotangent and tangent are my cofunctions. That means theta and 25 are complements. So theta plus 25 degrees equals 90 degrees. That means theta would have to equal 65 degrees. Boom. It's that easy. Again, please notice sine and cosine are cofunctions of each other. That means theta and negative 30 degrees are complements. Complements mean they add up to 90 degrees. Add 30 to both sides, we find out theta is can be 120 degrees. Notice it said find one value of theta. So that's one value. It works. There could be many. Let's find one value of theta. This time it's x. That satisfies this following. So cosecant and secant, again, those are cofunctions of each other. That means pi over 8 radians plus x radians has to equal pi over 2 radians. So x equals pi over 2 minus pi over 8. We're going to finish solving this, but let's get some, or simplifying this by common denominators. So 4 pi over 8 minus pi over 8. 4 pi's minus 1 pi, that is 3 pi's over 8. And those are my cofunction identities. Cofunction identities just say if I give you two cofunctions, their angles are complements of each other. They add to 80 or they add 2 pi over 80. Now we're going to move right on to our sum, our signs of a sum and difference, or the tangent sum and difference formulas. So here they are. These are our identities. They're a little different. The sign is different than cosine. Notice you put sine and cosine in the same values and they keep the same sign. Alrighty, this is the tricky one right here. The cosine A minus cosine A sine B. This one has to be in this order. The subtraction one has to be in this order. The adding one you can kind of move around a little bit, but it's okay. And then we've got our tangents. So let's jump right in and use them. Let's find the exact value of sine of 17 pi over 12. Now, as we discussed in class, when we take our unit circle, we can find all of our radians by treating the unit circle as 12ths. 1 12ths, 2 12ths, 3 12ths, 4 12ths, 5 12ths, 6 12ths. That's the first quadrant. But remember, if the fraction doesn't reduce, 17 pi over 12 is not on the unit circle. So what we want to do is we want to find two angles that are on the unit circle that add up to 17 pi. So I want two fractions that add up. So what I'm thinking, instead of finding the sine of 17 pi over 12, let's find the sine, and I'm going to leave them as 12ths for right now so you can see what I'm talking about. 9 pi over 12 plus 8 pi over 12. 9 pi plus 8 pi gives me 17 pi. Why did I choose these? These are actually on the unit circle. Because 3 pi over 12, that simplifies to 3 pi over 4. And 8 pi over 12 simplifies to 2 pi over 3. I divided both by 4. When we are adding with signs, so if I have the sine of A plus B, and I'm adding, so that's the one I'm going to focus on, the identity says sine A times cosine B plus sine B cosine A. I always like to write my sines first, my cosines second. That's what it is. But you can the identity. You know what? Let's write the identity says cosine A times sine B. Same thing. I should write what the identity says. Let's not get creative. Let's not get creative. My bad. I apologize for that. So looking at this, we know A has a value of 3 pi over 4. And B has a value of 2 pi over 3. I'm using these because these are the actual values on the unit circle. So we're going to say the sine of 3 pi over 4 times the cosine of 2 pi over 3 plus the cosine of 3 pi over 4 times the sine of 2 pi over 3. Using our unit circle, 3 pi over 4 and 2 pi over 3. So here's our unit circle. 3 pi over 4. Come on, why am I? 3 pi over 4, 3/4 of a pi. Right here, goodness gracious, 3 pi over 4. That's this point where we have cosine, sine, and 2/3 pi is this one where we're having cosine and sine. So if you draw out your unit circle, that's what you should get. So there's my A and my B. So the sine of 3 pi over 4, the sine of 3 pi over 4 is radical 2 over 2. I'm not going to refer back to that. You can look at it. Radical 2 over 2 times the cosine of 2 pi over 3. The cosine of 2 pi over 3 was negative 1/2 because we went to the left. Plus the cosine of 3 pi over 4. That's negative because we went to the left. Radical 2 over 2 times the sine of 2 pi over 3, which went up, radical 3 over 2. It's basically the point, we're writing down those points from our unit circle. When we do our multiplying, we're going to get negative radical 2 over 4 minus radical 6 over 4. And then when we combine them, we already have our common denominator, so we're going to say negative radical 2 minus radical 6 over 4. And that can't be simplified even though these are even because they are in radicals. Boom. Well, what if we're doing degrees? The degrees are going to be the same thing. So when we're looking at our unit circle, remember my degrees go 30, 45, 60, 90. We skip over 75. So 75 is not on the unit circle. So can we take some of those other angles that we've used? It's in quadrant 1, so that makes it nice. Can we take some of the other angles that we know and add or subtract to get 75? And I notice 30 plus 45 gives me the tangent of 75. So I'm going to do the tangent of 30 degrees plus 45 degrees. And then our tangent, since we are adding, we're going to use the tangent of A plus the tangent of B over 1 minus tangent A times tangent B. And I'm doing that because I'm adding. And we know A equals 30 and B equals 45. Alrighty, so tangent, so we're going to find the tangent of 30 plus the tangent of 45 over 1 minus the tangent of 30 times the tangent of 45. Now, 30, remember, tangent is sine over cosine. So the tangent of an angle equals sine of that angle over cosine of that angle. Well, the points we have, 30 is at the point radical 3 over 2 and 1/2. And then 45 is at radical 2 over 2, radical 2 over 2, radical 2 over 2. So we're going to do sine over cosine for each of those, or another way of saying it is sine multiplied by the reciprocal of cosine. So the tangent of 30, tangent of 30. So the tangent of 30 degrees is going to be, we took this one, we said 1/2 times 2 over radical 3. And the tangent of 45 degrees is going to be radical 2 over 2 times 2 over radical 2, which is 1. And this one equals 1 over radical 3. We hate radicals on the bottom, so move that radical to the top, keep the 3 down. Okay, there we go. So the tangent of 30 is going to be radical 3 over 3 plus the tangent of 45 is 1 all over 1 minus tangent of 30, radical 3 over 3 times 1. So if we do common denominators here on the top, I want to write one fraction on the top. This is going to 3 over 3. So this becomes 3 plus radical 3 over 3. Because 1 is a fraction, is 3 over 3. Add it to the radical 3. This one is going to become 1 minus radical 3 over 3. So again, we're going to have 3 plus radical 3 over 3, all over 3 minus radical 3 over 3. Let's go ahead and we will multiply by the reciprocal of the bottom. My goodness, I'm making a mess here. 3 plus radical 3 over 3 times 3 over 3 minus radical 3. The 3's are going to cancel out on top and bottom. So 3 plus radical 3 over 3 minus radical 3 multiply by, I'm changing the sign on the bottom, the denominator here, so I can get rid of the radical in the denominator. I'm hitting pause because I'm running out of time. So when I do my multiplying, I am going to get 9 plus 6 radical 3 plus 3 over 3 minus 3. It's actually 9 minus 3 because I forgot to square the first 3. And then when I simplify my fraction, I end up with 2 plus radical 3. Sorry, this last one was rushed. We'll get the last one in class.